All right, welcome to this lesson on comparing fractions. This is part one of a two-part series. So first we'll talk about situations where we would compare numbers. You do this every day in your life, probably without realizing it. So right now in our province of Manitoba, if you were outside, you can't be in a group that's larger than 5 to reduce the infection risk of COVID-19. So if you see a number that is bigger than 5, that is comparing numbers right there. Anything larger than 5 is not allowed. We also compare decimals. So if you're ever at the grocery store and you are shopping with your mom or dad, and you notice that you might want to buy something that's on sale or something that's a little bit cheaper, you compare decimals when you compare the prices of items, because in our place right here, our ones place, we're comparing the dollars and then we have our cents here. So that's comparing decimals. If you're into baking, you may find that you compare fractions. So let's say you want to make some banana bread, but you only have 2 cups of flour. Well, the recipe calls for 2.5 cups, so you may say there. So you would make the comparison that, oh, I don't have enough flour to make this banana bread. So that is comparing fractions and decimals in our everyday life. When it comes down to doing math problems, we have something called benchmarks. And benchmarks are kind of like your number intuition. So a benchmark is a known amount, something that you're familiar with. You can visualize it in your mind. And you may see numbers and you compare them to these benchmarks. So maybe kind of a beginner benchmark. This timeline right here, we've got the value 0. We have 1/2 and then we have 1. So these are good fraction benchmarks. If you can picture a half of something in your head, and then you can use that knowledge to compare it to other fractions. So benchmarks are really helpful when you're making estimates. So you're just kind of making a very educated guess about the value of something. Let's do some examples here. So it's very convenient to know when numbers are close to 0, close to 1/2, and close to 1, as shown in that image before. So the first thing you want to know is if the denominator is many times larger than the numerator, then the fraction is close to 0. So let me just provide a couple examples here. So let's say you have a number like 1/1000. That is super small. So out of 1,000 pieces, you only have 1. That number is super tiny. What about a number like 3/350,000? That's also a super small number. It's close to about 1 in 100,000. So that's also really, really, really tiny. So when you see numbers with big denominators, then you know that the fraction's pretty close to 0. Of course, you'd want to have this in lowest terms. I don't think this even reduces yet. That's 8. No, so this would be in reduced form. So you want to make sure when you're making these comparisons and these benchmarks that your fraction's in lowest terms, because if you see a fraction that's represented with a really big denominator, but the numerator is also big and it could be made smaller, then you're not doing the right thing to make these benchmark claims. You want to make sure it's in reduced form before you start making these guesses. Okay, so super large, denominator is many times larger than your numerator, then your number is pretty close to 0. Okay, so if you have a numerator that's about half of the denominator, then your fraction is close to 1/2. A couple of those examples might be like 7/11. Well, that's pretty close to 6/12, right? So if you were to divide, if you put this in your calculator, 7/11, and you get an answer that's pretty close to 0.5, then that's going to tell you that it's pretty close to 1/2. So when I punch this into a calculator, I get the answer, 0.63. Repeating. Just going from last class. So if you see that if you were to divide the numerator and the denominator and you get a number close to 0.5, you can make that benchmark kind of guess, okay, that's pretty close to 1/2. I saw this as 7 being close to 6 and 11 being close to 12, and I went, that's pretty close to 1/2. Another example might be like 51/100. Well, that's pretty close to, if that kind of resembles 5/10, which is 1/2. I should never write equal. I'm going to write is approximately. That's what those squiggles mean, kind of a guess. Okay, so 5 out of 10, you can kind of reduce. You can divide it by 10. This doesn't divide evenly into 10, but it divides roughly into 5. So that's another example of benchmarks. If you see that your numerator is roughly half of your denominator, then your fraction is pretty close to a half. If the numerator is almost the size of the denominator, then your fraction is close to 1. So if you have something like 11 out of 12, that's pretty close. If you were to draw chocolate bar 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll just roughly count that. 11 out of 12 looks something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can see that most of this is shaded in. Of course, very roughly, but you can see that this is pretty much almost 1. So if your numerator is pretty close to your denominator, then you can say that the fraction is close to 1. So where does this come into play? Well, you might be asked to, actually, let's do some more examples. Okay, so let's look at these fractions. Are they close to 0, less than a half, very close to a half, more than a half, or nearly 1? Well, 31 is super close to 30, so I could say that this is approximately 30 over 60. And then I can reduce that to get 3 over 6, which further reduces to 1/2. So that's very close to 1/2. What about 1 over 2,000? Well, we can't reduce that any further because 1 is already in its lowest form. So we're going to say that this one is super close to 0 because 2,000 is way bigger than 1. Okay, and then we've got 3 over 8. Well, that looks close to 4 over 8. Okay, it's less than 4 over 8 because 3 is less than 4. But then you reduce 4 over 8 to get 1/2. So this one was bigger than 1/2, so it was more. Very close, but more. This one's very close, but less. So this is kind of how you estimate using these benchmarks. So you can look at the values of the numerator and denominator. If you have something in the denominator that's really large and the numerator is really small, then you're close to 0. If your numerator is very close to the denominator, so let's say that one was 199,000 all over 2,000, you'd say that is really close to 1. I'm going to do the squiggly. It's not equal to 1, but it's super close to 1. Okay, let's keep going here. Oh, we've got some more examples. Here we go. So 97 out of 99. Out of 100, there's only, 2 less. I'm rounding 99 up to 100. That's why I say that. So that's roughly, 97 out of 100 pieces. That's very close to 1. So close to 1. 1,000 over 2,000. Well, you can just divide both of these by 1,000 and get rid of those zeros. So I'm going to divide by 1,000, divide by 1,000, and I wind up with 1/2 exactly. So that's exactly 1/2. 1 over 50, can't reduce this anymore, but 50 is still significantly bigger than 1. So I'm going to say that this fraction is close to 0. And 1/2, of course, well, that one's pretty easy. That is 1/2. That's a benchmark you should be familiar with. So we can use these benchmarks to estimate the sums of fractions. So what you can do is look at these numbers and go, okay, is it kind of close to 1/2? Is it kind of close to 1? Well, we've done this one before. 4 is 1 more than 3. So we can estimate that 3/8 is close to 1/2. 8/13 is close to 8 out of 12. And 8 over 12, reduces to, let me divide that by 2 to get 4 over 6. And then I'll divide again to get 2 over 3. So it's roughly 2/3. So if you see what I did there, I just kind of estimated. I just changed the value a little bit. So it's good to have these estimation problems are just good to kind of have for your math intuition. I cannot add because my denominators are not equal, so I will do some find the lowest common multiple and go ahead there. 4 over 6, and I get 7 over 6. Okay, 89 out of 91. It's 2 less. 89 is 2 less than 91, and 91's a pretty big number. So I'm just going to go ahead and say that that fraction is super close to 1. Same thing with 23 over 24. 24 is a pretty large number. You're only missing 23 pieces. So I'm going to say that that's also really close to 1. So these fractions roughly add up to 2. And that's estimating using benchmarks. So you'll notice I use this little squiggly line. I'm not saying that it's exactly 2. I'm just saying it's around 2. Very close to 2. A couple more here. 1 over 86. That's pretty tiny. So I'm just going to go ahead and call that 0 for the sake of, it's some number very close to 0. 6 out of 13, very close to 6 out of 12. So that's, whoops, that is going to be, and it deleted my work. No, it didn't. Fantastic. 6 out of 13, very close to a half. I can add this fraction because, well, 0 is just 0. Okay, we've got 1/2 plus 1 all over 100 million. That is a super small number. That's almost negligible. It almost doesn't matter. It's so small. So it is 1/2 plus 0 equals a half. Whoops, not 12. My goodness. 1/2. Okay. Dun, dun, dun. So with more experience, you can add in other fractions to your benchmark library, including 1/4 and 3/4. Those are ones that, especially when you're dealing with money, can kind of become more familiar. You know, you got quarters with money. You might round to the nearest quarter. So with more experience, hopefully you can add these to your benchmark library. So 1/4 and 3/4. So this one here, 3 over 11, pretty close to 1/4. It's not equal. It is, whoops. Okay, so 3 all over 12. 9, oh goodness, 9 over 14. That's pretty close to 10 over 15. If I just add 1 to each, pretty close to 10 over 14. Pardon me, 10 over 15. 10 over 15 reduces to, excuse me, I'm going to divide both of these by 2. I can't divide by 2. I'm going to divide both of these by 5. And I end up getting 1/3. Oof, 3/4. My goodness, I'm having a rough go here. 9 over 14 is close to 10 over 15. And I can divide by 5. Yeah, there we go. Sorry, 2/3. My goodness. So it's roughly 2/3. So not part of our library, but also some numbers you should try to be familiar with. Oops. Keeps wanting to go forward. Okay, I'm going to bring this up to 12 to get 3/12 all over 8/12. And I end up with 11 over 12, which is pretty close to 1. Okay, so that is just talking about benchmarks with fractions. Got a brief bit about decimals and benchmarks. So decimals are often more familiar to us. You may see that 0.0000000007 is very close to 0, and then 0.488 is pretty close to 0.5, and then we have our 0.998 being very close to 1. Okay, so one thing to remember is that with each decimal place, the number, excuse me, with decimals, that each place in a number is worth 10 times as much to the number on its immediate right, and 100 times as big as a place 2 to the right. So 0.4 is 10 times more than 0.04. 9.06 is 100 times bigger than 0.0906. So every time you move on that decimal, it's 10 times less, 10 times less, 10 times less, etc. So let's visualize that with a diagram. 0.4 is 10 times more than 0.04. So I'm going to represent 0.4 on the left and 0.04 on the right. So this is a 10 by 10 grid. 0.04 is actually 4 out of 100. And this guy here is 40 out of 100. So I would do 1, 2, 3, 4. Okay, and then my one on the left is actually this, all these rows here. So Pretty much, yeah, all of these squares up here. The first